In this video, we're going to look at how we can use the tools of trigonometry in the context of right triangles. So let's first review a little bit about trigonometry in the context of circular motion. Suppose we have an angle with a measure of theta radians, and we have a circle centered at the angle's vertex, and we'll say this radius is r units long. Then this terminal point has some location relative to the vertex of that angle. We know that the x-coordinate, or the terminal point's distance to the right of the center of the circle, is equal to r times cosine of theta. And the terminal point's distance above the center of the circle is equal to r times sine of theta units. Now, one of the things we'll recognize is we can actually draw a right triangle into this diagram. So I'll zoom in a little bit. I'm going to draw a right triangle here. So we have a horizontal leg, a vertical one, and then the hypotenuse right there. Now, we actually know the lengths of each side of that right triangle. So we know that that vertical side is r times sine of theta units long, and this horizontal leg is actually r times cosine of theta units long, and the hypotenuse of the circle is r units long. So make sure you see that this hypotenuse, it's like the distance from the center of the circle to the outside of the circle, which is r units long. So we have a hypotenuse of r units, vertical side length of r times sine of theta units, and a horizontal side length of r times cosine of theta units. And therefore, when we're looking at right triangles, we can use the tools of trigonometry to think about the side lengths of the right triangle. So let's formalize this a little bit. If we have a right triangle, we say it's in standard orientation if one of the shorter sides is horizontal, the other shorter side is vertical. The angle of interest is at the bottom left corner, so we'll say theta is down here in the bottom left, and then the right angle is actually in the bottom right of this triangle. So if we have a triangle that looks like this, we just say it's in standard orientation. So we'll assume that this right triangle has a hypotenuse that is r units long, a horizontal side length of x units, and a vertical side length of y units. So what we just saw is that x is actually equal to r times cosine of theta, where theta is this angle measure of interest down here in the bottom left. We also saw that y is equal to r times sine of theta. And then we can say a little more. We can actually say that just based on this first equation, we can say that cosine of theta is equal to x divided by r. It's the measure of that horizontal side in units of the hypotenuse of that right triangle, which is what this ratio represents. And then from the second one, we can say that sine of theta is equal to y divided by r. Again, this is because sine of theta represents the measure of this vertical side, which is y units long, in units of the hypotenuse of this right triangle, which is r units long. Then we could also say that tangent of theta, which is the slope of that hypotenuse, that's going to be equal to y divided by x, because the slope is the measure of that vertical side in units of the horizontal side, which is represented by the ratio y divided by x. Okay, let's quickly use this idea of right triangle trigonometry in a couple different contexts. So let's look at this first one, where we have a right triangle that's drawn in standard orientation. Hypotenuse of this triangle is 10 inches long, and this angle of interest down here is 0.8 radians. So we will determine the lengths of the other two sides of this triangle. So we know that x should be equal to 10 times cosine of the angle measure, 0.8. Cosine gives us the horizontal length, the length of that horizontal leg, measured in hypotenuse lengths. Hypotenuse is 10 inches long, so x is equal to 10 times cosine of 0.8. And that's approximately equal to 6.97. So that horizontal leg is about 6.97 inches long. On the other hand, y is going to be equal to 10 times sine of 0.8. Sine of 0.8 gives us the vertical side length in units of the hypotenuse. And 10 times sine of 0.8 is approximately 7.17. And therefore, that vertical side is about 7.17 inches long. Let's look at one more example. So let's suppose we do not know the angle measure down here in the bottom left, but we know the lengths of each side. We can actually use what we know to determine the output values of the trigonometric functions. So for example, we know that cosine of theta should be equal to x divided by r, or the measure of the horizontal side in units of the hypotenuse, which is going to be equal to 6.12 divided by 8, and that's approximately equal to, actually it's exactly equal to 0.765. On the other hand, sine of theta will be equal to the measure of the vertical side in units of the hypotenuse length r. And that's going to be equal to 5.15 divided by 8, and that's equal to 0.64375. And then on the other hand, tangent of theta is equal to, well, tangent of theta represents the slope of the hypotenuse, which is going to be equal to the vertical side measured in the horizontal side, which is going to be equal to 5.15 divided by 6.12, and that's approximately equal to 0.84. So the hypotenuse of that triangle has a slope of about 0.84. So using what we know about the sine, cosine, and tangent functions, we can actually determine output values even if we don't know the measure of that angle, if we know the lengths of the sides of that triangle.